All right, another name that I want to introduce is the name radius. I think you know what is a radius. Do you know what is a radius?
Yes, I know it.
A line that starts from where?
It starts from the center.
And then it goes and touches the circumference. Am I right?
Yes.
Like the orange line, that one, we can call it the radius. Are we together?
Yes.
Good. All right. Now, for theorem number 1, you have enough information. But I know here with the circle, there are other names. I'll give them to you little by little. But I know they're going to start by giving you many names. The chord, the radius, the diameter, the tangent, the secant, the major arc, the minor arc, semicircle. Don't worry, we'll catch up later. But we'll be ahead, don't worry. So now let's come here. There is this theorem. This theorem is the one that is called midpoint theorem. Do you see that word midpoint theorem, the one that I wrote in yellow?
Yes.
It's going to be your reason. So every time when I show you a new theorem, I tell you the name. That name, it is a reason. Because in geometry, you give statement and reason. All right, so here we go. Listen to me. Here they're telling you, maybe before I can actually show it there. Let me do it here on this side first, and then we will go to it so that you can actually understand. Don't worry, your job is just to watch. I'll send you the link for the videos. You'll always get them all the time. All right, so here we go. So we have a center of a circle. And then we also have, let's put a chord. I'm going to call that chord, I'm going to use the same letter. Okay, let's call them PQ for now. PQ. Let me draw another chord. The blue one. I'm going to put it that side. I'm going to call this one here. Let's call it something like maybe RT. Can you see the blue and the orange are chords? Am I right? We'll put the letter as its chords. Are we good?
Yes.
Now, the first theorem, this theorem, it says, okay, let me put 0 by the center. They love to use 0 for the center. The rule says, if you draw a line from the center of the circle, a line from the center of the circle to the middle of the chord, they will call it to the midpoint of a chord. Draw a line from the center of the circle to the middle of the chord. I'll call the middle M here, which means PM must be equals to MQ because M is in the middle of PQ. Are we together? Now, the rule says, if you draw a line, they'll call it a line segment, a piece of a line segment. You'll see when I show you. When you draw a line from the center of the circle to the midpoint of a chord, that line, the red line, will make 90 degrees to the chord at that point M. So it will be perpendicular to the chord. So that means I can now put the 90 degrees there. You know the box, the small box means 90 degrees. Am I right?
Yes.
Good. Let's do it to the other side as well here. So if I draw a tangent to the middle of the blue line, right to the middle, meaning this side equals to that. Let's call this one letter Z. So it means it will form 90 degrees. It will be perpendicular to the chord. Now, I'm going to say it the way they say it. They say this. A line drawn from the center of the circle to the midpoint of a chord is perpendicular to the chord. All right, let's come here. Here we go. It's already written for you here. I'm telling you, it says what? If a line is drawn from the center of a circle to the midpoint of a chord, like what I was showing you, then that line is perpendicular to the chord. So that means where we've got angle M1 and M2, there must be 90 degrees. So that means I can now put what I'm putting in red now. I can say is 90 degrees. Don't worry about these other dotted lines. You don't have to worry about them for now. Just forget about these ones for now. I'll tell you about those lines. A line drawn from the center of the circle to the midpoint of a chord, it bisects. No. It's perpendicular to the chord, I mean to say. Did you understand that theorem?
Yes.
Now, the short way of writing it is to write what I'm underlining in red. Midpoint chord. It's what I told you here. Midpoint chord theorem. That will be your reason. Now, we can also do the converse.